Hey guys, so today we are going to wrap up our learning of topic 16. So we're going to finish up with probability models notes. So we're going to finish talking about our last section of topic 16 and then we'll start assessing tomorrow. So to kick things off, we have probability models. We're going to look at some different vocab that we've actually talked about already a little bit when we started on Monday. But we're going to go into it a little bit more. So our first blank here, we have some vocabulary. We are going to fill in an action is a process with an uncertain result. And then our next set of vocabulary here is sample space. And we talked about that already as well. A sample space is the set of all possible outcomes for the action. So looking at some examples here, the first one says list the sample space for a normal six-sided die. So where, again, a sample space is all the possible outcomes. So we're just going to list all the possible outcomes of rolling a die. And that would be 1, 2, 3, 4, 5, and 6. So that is our sample space. And then we have another example that says list the sample space for the spinner pictured. So we're just going to list all of our possible outcomes. So we're just going to list each space of the spinner. So we have yellow, blue, red, white, and green. So we just list out each of those. And that is our sample space. Okay, so when we move on, we're going to talk about what a probability model is. So I'm just going to scroll up, and that is our next set of vocabulary words here, and that is simply a probability model. And a probability model includes the action, the sample space, and all event probabilities. So a probability model consists of an action, its sample space, and a list of events with their probabilities. The events and probabilities in the list have these characteristics. Each outcome in the sample space is in exactly one event, and the sum of all the probabilities must be 1. So if we take a look over here, it says action, 1 spin of the spinner. So we've got our spinner here, and the action would be 1 spin. Our sample space is all of our possible outcomes. So we have red, red, blue, red, blue. And then our probabilities. So the probability of getting a red is 1, 2, 3 out of 5, so 3/5. And our probability of getting a blue is 1, 2 out of 5, so 2/5. So we can check to see if this is a probability model, and we would do that by adding our probabilities together. So 3/5 plus 2/5 equals 5/5, and 5/5 equals 1. So that shows us that that is a probability model. Okay, so let's go ahead and continue. And take a look at the back. We have some practice here, and we are going to show which of these, we're going to see which of these show a probability model. So we're going to look at our spinner here. It looks a little different, a little bit strange with letters and numbers, but we are going to take a look. So it says, which list shows a complete probability model for the spinner? So we're going to look at A. It says the probability of an even number. So I've got an even number. That's going to be my 2 and my 8. And the probability of an odd number. Okay, so then I'm going to have, I'll change up my colors here, 1 and 3. So if I want to find the probability of an even number, it's going to be 2 out of 8 because I have 8 possible outcomes here, and 2 of those are even. The probability of an odd number is also 2/8 because I have 2 odd numbers out of 8 possible outcomes. So remember, we want to add these together, and if I do 2/8 plus 2/8, I get 4/8, and that does not equal 1. So that is not going to be a complete probability model. So I'm going to erase these a little bit here. And here we go. We're going to look at the next one. All right, so B is telling me the probability of a letter. Okay, so we have 4 of our 8 sections of our spinner are letters, so 4 out of 8, and the probability of an even number. So again, my even numbers were 2 and 8, so I had 2 out of 8. So again, I want to add my probabilities, and I'm looking at 4/8 plus 2/8, which would give me 6/8. And again, that does not equal 1, so this is not going to be a complete probability model. All right, so let's take a look at C. We are now looking at the probability of a letter, right? So I've got my letters down here, which is 4/8, and the probability of a number. And I've got, my numbers up here, and I have 4 numbers. So now I have 4/8 for my probability for my letters, and I have 4/8 for my probability for my numbers. And if I add 4/8 plus 4/8, I get 8/8, which does equal 1. So that is going to give us a complete probability model. So just to make sure that we don't have another one as the option, I'm going to take a look at D, and we're going to see what that one would give us as well. So let's take a look, and we would look at the probability of a letter, getting a letter, which we just said was 4/8. We've got those. And the probability of an odd number. So then we would have 2/8. And again, we kind of did that already up here for our letter and our even number, but if we add 4/8 plus 2/8, we get 6/8, which is not equal to 1. So that is not going to be a complete probability model. So hopefully what you're seeing here is that when we are finding our probabilities, it will be a complete probability model if when we add all of our probabilities together, it equals 1. So let's take a look at our next problem. We have number 2 here. We've got this example. And it says you choose one of the cards below at random. What probability statement could you add to the probability of a letter, which is 1/4, to make a complete probability model? All right, so now we're being told, so we have our letters here, right? We've got 3 letters. And we're being told it's 1/4. So if I look at this, I have 3 letters out of 12 possible cards. So 3/12, if I reduce that, it does equal 1/4. So that's where my probability of choosing a letter, that 1/4 came from. So I want to know which probability statement I can add to this one, to 1/4, to make a complete probability model. So let's take a look at our choices. We have the probability of choosing a number equals 1/4. Well, if I look at all my numbers here, I have 9 numbers out of 12, and 9/12 does not equal 1/4. So this statement is already incorrect. When the probability of choosing a number is not 1/4, so that doesn't work anyway. And even if we would have added 1/4 and 1/4, that would have given us 2/4 or 1/2, and that would not have been 1. So we're looking at the probability of a letter 1/4 and the probability of a letter which equals 1/4. Well, now we're adding the same probability, not all of our probabilities, because we already had the probability of our letter is 1/4. So we can cross out the second one as well, because that just doesn't make sense. It doesn't add together all of our probabilities. So this leaves us with C, and it says the probability of a dark gray card. Well, our letters were on light gray cards, and that was 3/12, which was equal to 1/4. The rest of our cards are dark gray, and if we count those up, those are the same as our number cards, but we have 9 dark gray cards out of 12, which is 9/12, which reduces to 3/4. And if I add 3/4 plus 1/4, I get 4/4, and that equals 1 whole. So C, my dark gray cards, is what I would need to add together with the probability of my letter cards, which was 1/4, to get my complete probability model. Okay, so again, probability model, they have to add up to 1, and we have to add all of our probabilities together to get our probability model. So let's take a look at question number 3. It says, in a bag with 20 marbles, there are 5 blue, 10 green, 2 yellow, and 3 red. Fill in the blanks below to make a complete probability model. Now, this is really nice because they actually tell us what our total number of marbles is. We are told there are 20 marbles total. A lot of times they're just going to give you the colors, and you're going to have to figure that information out yourself. This time, though, they said we have 20 marbles, and then they list out all the different colors. We have 5 blue, 10 green, 2 yellow, 3 red. So I've got all of those right there. So now I just want to come down here and find the probability of each color. So for blue, there are 5 blue out of 20 total. So we're going to list 5 over 20, which reduces to 1/4. So the fraction 1/4. All right, then we're going to look at green. We have 10 green. So I'm going to list that as 10 out of 20, because 10 green out of 20 total, which is going to reduce to 1/2. So the probability of green is 1/2. The probability of choosing a yellow, we have 2 yellow out of 20 total, which is going to reduce to 1/10. So my probability of choosing a yellow is 1/10. And I have 3 red out of 20, which I can't reduce any further. So that is just going to be 3/20. Now, remember, what I want to do is add together all of my probabilities to see if they equal 1, to see if they're a complete probability model. Now, when I add fractions, I do need a common denominator. So if I look at my reduced fractions, that's not going to be as easy. So looking at 1/4 plus 1/2 plus 1/10 plus 3/20, that is not as easy to add together, but I do have my original fractions out of 20. So I have 5/20, 10/20, 2/20, and 3/20. So I'm going to add those together. I'm going to add 5/20 plus 10/20 plus 2/20 plus 3/20. And if I add those together, 5 plus 10 is 15, plus 2 more is 17, plus 3 more is 20/20. And 20/20 is equal to 1, so this does make a complete probability model. Okay, I hope this makes sense. I hope this kind of clarifies a little bit for you what a sample space is, what an action is, what an event is, and then also what a complete probability model looks like. If you have any questions, feel free to go back in the video and rewatch any of the parts. Again, if you needed to pause it at any point, go back, whatever you need. You can also raise your hand and ask your teacher, and we are happy to help you. The next activity you're going to be working on is posted in Google Classroom. So just go ahead and click back there and you'll be working on that activity next.